Hello everyone, this is Martha once again from the Academic Support Center. This video is going to be to introduce logarithmic functions. And we're going to talk about where they come from, how to change between logs and exponents, and how to evaluate them, and a little bit about why that's important. So let's start off where they come from. They actually come from exponential functions. A quick review, an exponential function is f of x equals b to the x. Another way that we write it is y, because f of x just means y, equals some base raised to the x. Now, logarithmic functions or log functions are inverses of each other, which means if we know one, we can find out the other one, which can be quite helpful. So let's remember that the process to find the inverse of something, we switch the x's and the y's, and then we solve for y. So let's switch this. So our y equals b of x, b to the x. Let's say x equals b to the y. Well, how do we solve for y? The mathematicians have found and developed this trusted, works, it's awesome, and that form is that y equals a log with a base times x. And knowing that this is always going to work helps us. And it also provides a way that we can switch back and forth between the two different forms, and it stays the same, it stays true. So I want to make a nice, well, let's make it nicer. A box up here just kind of as a reference. So we've got the y equals log base b times x. Well, to switch between, we remember to bring the base down here. The log is kind of accounted for, and then we're just left with x. So b to the y equals x. So this is the process of how we change between them. And also, if we want to switch between, if we've got b to the y, we just drop it, the exponent goes outside. The b becomes the base of our log, and then we've got the x left over. So let's try some changing between and evaluating what they mean. So let's do 2 equals log base 5 of x. Okay, so now we have to solve for x. How can we do this? We remember to bring down the 5 as our base, so 5 squared equals x. Well, here, that I can solve. That means that x equals 25. Okay, sweet, we can do that. Let's try another one. Let's do 3 equals log base b times 64. Okay, so now I've got to solve for this base. What's this base? So we bring it down here. B cubed equals 64. Okay, I know that 4 times 4 is 16 times 4 is 64. So B equals 4. I should have done that. B equals 4. There, I'm evaluating it that way. Now we can also change between, we were switching from logs to exponents. We can switch from exponents to logs as well. So let's give it a try. 12 squared equals x. Now we can find this out pretty easily, but let's follow the pattern and see what happens. The exponent goes what I like to think of on the outside. So 2 equals log, my base is 12, 12x. Let's try another one to switch between. We've got b cubed equals 8. And just to switch between, see what it goes, our exponent kind of goes on the outside. So 3 equals log base b 8. Okay, these I can This is just the process of switching between. And we'll do one more, just to try. E is Euler's number, and it's really useful. It's a pattern that we see so much in nature, and we're going to talk a little bit more about it. But e to the y equals 9. Okay, so I go, my exponent kind of goes outside. Y equals log base e, which is the natural log, at times 9. So that's just switching between. So it's getting a little messy on here, so we're going to clear it all off, and we're going to do some practice evaluating. So let's choose some fun ones. So let's evaluate or solve for log base 2 16 equals what? So I've got to remember that this outside, this what is my exponent. So 2 to the x equals 16. And I ask myself, okay, what 2 to what power equals 16? So 2 times 2 is 4, times 2 is 8, times 2 more is 16. So 2 to the 4th equals 16. My x equals 4. All right, let's do another fun one. Log base 7 times 1/49. So let's switch this around. Equals x, my don't know. I know that my base is 7, my exponent is x, and then I say, okay, 1/49. 1/49. Okay, and I know that 7 times 7 equals 49, but because it's in the denominator, my exponent is going to be negative. So 7 to the negative 2 equals 1/49, which means that my x out here, x, equals negative 2. So far, so good. Let's do another fun one. Log base, I know, probably not so exciting, but it will get there. Log base 25, 5 equals what? So I've got 25, my exponent is x, and then I've got 5. Okay, let's see, I know that 5 times 5 is 25. So I'm going to say that 25 to the square root is 5. And anytime we have a root power, whatever number goes up here is a denominator in our exponential form. So 25 to the 1/2 equals 5. So in this case, my x equals 1/2. Let's do one that looks a little tricky. Log base 2, the 5th root of 2. Okay, so I know that 2 is my base. My x is what I don't know, and I know that I've got this 5th root of 2. Well, then I can just remember again that if I've got a root, whatever number is the root goes in the denominator. So 2 to the x equals 2 to the 1/5. I'm just switching the way it looks here. And because my bases are the same, I know that x equals 1/5. So this was just an introductory video talking about how log functions are the inverses of exponents, and that we can switch between them and then evaluate that way. So the next video is just going to cover 2 basic principles, and then we'll have some graphing techniques. Have a great day.